We're going to start with solving LeetCode problems, and the very first patterns that we'll be focusing on is the sliding window pattern. And I'm going to try and solve the very first problem, which is to find the maximum average subarray. So let's go and take a look at the question, right? So I've already solved it. I didn't want to try solving it the very first time and then spend a lot of time just to debug issues, but I think, yeah, it should be fairly straightforward. It did take me a while to figure out some edge cases and stuff, but I did end up solving it. So basically, you know what? I'm gonna draw an example so that it makes a lot more sense. So for example, let's consider that you're given an array, right? So in this case, I'm gonna take one of the test cases that I did solve. 6, 50. Then what else? Was it 3? Yeah. Right, so we have this array of positive and negative numbers, right? And we're given an additional integer as well, which is called k, right here. So in one of the test cases, the k value was 4. And the idea is to find the maximum subarray of length 4 that has the highest average. So the very first subarray of length 4 can be this, and we would calculate the sum of all these elements and try to find the average. So in this case, we would calculate the sum and divide it by 4, which would give us an average x, and then we would calculate the next subarray of length 4, maybe y, and then we would calculate the next the sum of the next subarray with length 4, which in this case would be this, and then we would calculate the sum and divide it by 4, which would give us the average z, right? So once we've calculated all of these different subarrays, we're supposed to return the maximum average for all of these different subarrays, right? So that's kind of the overall problem, and the way that we solve this is by using a sliding window pattern. What I did is, you know what, let me erase all this stuff. So what I did is that I initially, before even I go into an iteration, what I did is that I initially calculated the sum of the first 4 elements and then figured out the average for it, right? So I'm holding this variable, have the average, and then what I'm doing is that for all the next iterations, I am subtracting this value, but I'm adding the next value to the average sum. Like this is like the global variable that we have. And then during each iteration, I'm subtracting the previous value and then adding this next value. And then when the next iteration happens, so we would take all of these values, and in this case, I'm subtracting 12, but then I'm adding 3. And each time that I'm subtracting and adding, subtracting the first element and adding the last element, I'm making a comparison to the global average to see if the resulting average is lesser. No, wait, it's higher than the global average. If it is, I'm replacing the average value, and then at the end of the iteration, I'm just returning this average, right? So I hope that made sense. I'm gonna try and solve this out in Java. I think it'll make a lot more sense. So the very first thing is to declare like the final value that we're planning to return, which in this case would be a double. What should I name this? Maybe maximum average, I guess. Yeah, let's just go with that. And so I want to have another pointer so that we keep track of the first start of the subarray. I can keep track of the last element within the for loop itself, because I want to make sure that we don't cross the length of the array. So, but for the start, I'm going to make use of another variable. Probably we'll just go with start. Pretty original. And the very first thing that we talked about is to calculate the average for the first 4 elements. So that's what I'm going to do. I'm going to write a for loop for just the first k elements, right? So int I equals 0, I is less than k, plus plus, fairly straightforward. And then I'm just going to add this to average here so that, you know, like I don't want to create another variable just to store the temporary first 4 sum. So I'm going to access that and then add it to this, and then at the end what I'm going to do is I'm going to set max average equal to max average divided by k, which would give us the actual average. And then there's one more thing that I want to do, which is to wait, let's just I'll just come back to that later, but I still need to have another variable to still store the sum, because we don't really need the average when we do the next iteration, but we need the sum because we need to subtract the first and the add the last element. So we need the sum rather than the average. So I'm going to create another double store local sum equals 0, and then before I replace it with the average, I'm going to set this to local sum so that we can keep track of the sum, because we need that during our next iterations and stuff. Right, so now with the kind of the important part, we're doing the actual iteration for each one of the subarrays. So I'm going to start with trying to think, where should I start with? So basically we need to start from oh yeah, so we need to start from k, and then I should be less than the length of the array, and then I plus plus. The reason I'm starting with k because I need the last element, right? So in this case 0, 1, 2, 3, and 4. I need to keep track of this last element so that I want to make sure that we don't cross the limit of the array. So so initially we would start the last element for 4, and then we would increment it accordingly, right? And so we need to subtract, right? So yeah, so local sum would be to subtract from local sum the very first value. So we need to subtract 1, basically the previous value. So in that case it would be, what would it be, we put it to start plus plus here so that we can keep track of start minus 1. So basically this is another flag. Let me put another color. We have start here, right? So when we do every single subarray iteration, so in this case we are taking all these subarray, we need to subtract start of 0. So before every single subarray calculation, I'm incrementing start so that I can do s minus 1 and then subtract the very first element. So that's kind of the idea here. Or we could do the other way around, use the start as is, and then before we do the let me do that. That's a lot more. Before we exit the iteration, I can do stars plus plus. I think that will make a lot more sense. But the basic idea is you subtract the very first element, and then but you also add the last element. So in this case, it would be num of I, and so this is the sum. We also need to calculate local average. So I'm going to create double local average and then local sum divided by k, which is giving us the average for the subarray. And I need to make a comparison to see if this is less than local average, meaning that let me finish this off. So meaning that the subarray, the local subarray average sum that we calculated, is it actually greater than the maximum average global variable that we have? In that case, we would need to replace the global variable, not exactly global, but the overall result that we're setting out with the local average. And I'm trying to think if there's anything else that we need to say. Let's just run this and see. I think that is all. But maximum average, and then let's run. Oh wait, I'm getting an error. Oh, it's nums, my bad. Yep, I'm gonna submit it, see if it all passes all test cases. Right, so it just did. So that's kind of the idea, guys. We try to use sliding window pattern to solve this problem, and we're keeping track of maximum average as well as the local sum, because we need to keep track of the sum most importantly, because every single iteration we need to subtract the very first and add the very last. And we need the average so that we can compare the local average with the global average and replace that value before returning after the iteration, right? All right, guys, so that's it for today. I'm gonna try and solve the next sliding window pattern problem tomorrow, so keep an eye out for that.